Hello and welcome. In this video, we're going to be discussing how to solve absolute value inequalities like the ones you see on your screen. So if you haven't watched the video on how to solve absolute value equations, I would strongly encourage that you do that before viewing this video, because we're going to be building on the ideas that we discussed in that video. So one of the ideas that we discussed was the meaning of absolute value, these straight vertical bars. Really, they're measuring distance from zero. So when I look at this first statement, it's saying that I want distances from zero that are less than or equal to 2 units. So let's draw out where those are on the number line. So if I want my distance from zero to be less than or equal to 2 units, well, let's start by finding where the distance from zero is exactly equal to 2 units. So there's 2 places on the number line where that happens. One place is at 2, the other place is at -2. So if I want my distance from 0 to be less than or equal to 2, that means I'm going to be in here somewhere. So what that means is that u plus 7 has to be sandwiched between 2 and -2. So when I set up my inequality, the way I'm going to set it up is like this. U plus 7 has to be sandwiched between 2 on one side and -2 on the other side. And so we know that we have to be less than or equal to 2 if I want to be in this region. And I know that if I want to be in this region, I also have to be greater than or equal to -2. So if I put the appropriate inequality in, I'm left with that. And so now I'm just left solving this inequality, or I should say these inequalities. So what I'm going to do first is subtract 7. And I can solve both inequalities at the same time. So that's what I'm doing right now. So if I solve the first one, I've got -9 is less than or equal to u. And then the second one, u is less than or equal to -5. And that is my answer. So if I want to graph out that solution, well, what I've just discovered is that u is sandwiched between -5 on one side and -9 on the other. So I can put closed circle at -9 to closed circle at -5. In interval notation, my left endpoint is -9, and since I'm using a closed circle, I have the square bracket. My right endpoint is at -5. Again, closed circle is my square bracket. So my solution would be whatever format is being asked for. But it would either be the graph that I have, or that interval notation, or the inequality. So what I want you to notice about that first one is that I started with an absolute value is less than or equal to. And that really sandwiched me between 2 numbers. Let's take a look at what happens when I have a greater than absolute value. So if we look at the second one, this one says that we want distances from 0 to be greater than 2 this time. So let's draw out where those distances, or where those values would be. So if this is 2 on one side and this is -2, that marks out where my distance from 0 is equal to 2. But now I want my distance to be greater than 2. So on the number line, that's really all of those numbers out here. And it would also be all of these numbers to the left of -2. So now I just need to find a way to describe each of those sets of numbers. So when we look at the first set, this guy, all of those numbers are less than -2. So since I'm taking the absolute value of x plus 3, I want x plus 3 to be less than -2. So that's going to be my first inequality. When we look at the second set of numbers, all of those numbers are greater than 2. And again, since I'm doing the absolute value of x plus 3, I want x plus 3 to be greater than 2. And since the 2 intervals are not connected, since they're separated by a gap, I'm going to use the word or in the middle. And so now all I want to do is solve each one of those inequalities separately. So if I solve the first one, I would subtract 3 from both sides. And that gives me x is less than negative 5. Or, when I solve the second one, I'm going to subtract 3 from both sides. And that gives me x is greater than negative 1. So if I graph out that solution, well, I've got negative 5, I've got negative 1, and so I want all values of x that are less than negative 5, so open circle and to the left, or I want all values of x that are greater than negative 1, so open circle and to the right. If I were using interval notation, notice I have 2 intervals with a gap in the middle, so I'm going to be using the union. So if I want to describe this first set of numbers, those would be all the numbers starting at negative infinity all the way up to negative 5. And then again, rounded parenthesis because I've got an open circle, I don't want to include that number. And then I'm going to join that interval to the interval that starts at negative 1 and continues to the right forever. So my right endpoint would be positive infinity, and then again I would use the rounded parenthesis. So that is my answer. So notice when I start out with the absolute value is greater than a number, then I'm not sandwiched between two numbers, but instead I'm actually going off kind of to infinity on one side and then to negative infinity on the other side. So there's a difference, and the difference between solving inequalities, absolute value inequalities that are less than or equal to, versus solving absolute value inequalities that are greater than, just in terms of which numbers on the number line you're interested in. Okay, so here's a problem that I want you to try. Pause the video and then restart after you've given it a shot. Okay, so first thing to notice about this guy is that it's a greater than or equal to. So we're interested in distances that are greater than or equal to 6. So if we draw out our number line, here's 0. On one side we've got 6. On the other side I've got negative 6 because I'm marking out where the distances from 0 are equal to 6. So if I want distances that are greater than or equal to 6, that's going to be all the numbers out here and all the numbers out here. So this is going to be that OR case again. So if I want to describe this first set of numbers, those are going to be all the numbers that are less than or equal to negative 6. And notice I'm doing the absolute value of v plus 4. So when I set this up, I'm going to have v plus 4 is less than or equal to negative 6. Or, because again, I've got two sets of numbers with a gap in the middle. And if I look at the other set, these numbers are all greater than or equal to 6. So I want v plus 4 to be greater than or equal to 6. And now I just solve each of these inequalities individually. So subtract 4, I get v is less than or equal to negative 10. Or subtract 4, v is greater than or equal to 2. If we graphed out our solutions, I'll do a number line for v. Here's negative 10, here's 2. V is less than or equal to negative 10 would be closed circle and to the left. V is greater than or equal to 2, closed circle to the right. In interval notation, to describe this first set of numbers, my left endpoint is negative infinity, my right endpoint is negative 10, square bracket, and then I want to join that to the interval starting at 2, square bracket, because I want to include that number, and my right endpoint would be infinity.